So this is the last part of the chapter 12, that is the relative motion of two particles using translating axes. So let's start one by one. So we have a axis of, I will call it as origin O, the coordinate Z, and then the coordinate Y, and then the coordinate X. So this is the, let me call this one as the fixed reference frame. Okay. And then this one is particle A, and that particle moves along the path here. Let me show it so as you can notice that it moves this along the path. And this one is particle B. Okay. And this particle moves in this path. So the question is, you can think this one as like, there is a car here, and then this car moves in that direction, and there is another car here, and this car moves in this direction. And then the question is, and then I can call this one as a car A. So this one as a car A, and this one as car B. So for an observer here, so observer, it means that somebody, okay, so say that person. Let's call him as John. Okay, that John sees that, for example, car A moves 50 mph. And then there is someone inside this car, and there is someone inside this car. And then for John, this same person, car B moves with 60 mph. Okay, this is just a very simple case. And then the question is, for someone inside car A, what's the speed of or velocity of car B? So for someone in car A, what is the speed of car B? Okay, or vice versa. It is the other case is also possible. So for someone in B, for example, what's the speed of the car in the A? Okay, this is what it looks like. Why do we need this additional information of 60 and 50 mph? Because it will help us to solve the problem. Okay, then we have another coordinate axis O with coordinates y and then x prime and then z prime. And this O is fixed. The second coordinate axis, this one, is translating. That's very important, that it just translates. There is no rotation. This is very important, because if it rotates, the things will get different. And also it doesn't accelerate, because if it accelerates, then we will not be in inertial reference frame. So anyway, so for this coordinate axis, the particle A has a position vector shown as RA. Okay, position vector means just the position. Okay, it is just a vector that shows the position of an object. So that's not a big scientific. Let me add it here. Position vector. Okay, it shows the position of an object. And then we call it as a vector because it shows the direction as well. So that's the reason we call it as a position vector. Okay, it's not so big scientific term. And then for an observer in O, the particle B, one more time. So let me start the opposite case. Here, and then here. Okay, and this one will be the RB. Okay, so what it means is that with respect to John, the car A moves 50 mph, car B moves 60 mph. Now the question is, with respect to this translating axis, okay, what's the speed of what's the position of particle B? Then that will be equal to, let me add that one as well to solve the things easier. So I will add it here as RBA, and then, okay, so let me write it better way so it is not visible here. So I will call it as O prime. Okay, so that is what we are looking for. So we are looking for RBA. So let me write it here. RBA is the position of B with respect to A, where A translates. I mean, similar to here, yes, the car A translates, moves, and car B moves. The question is, what is the position with respect to A? What's the velocity with respect to A? And these are the questions that we need to answer. And then simple vector algebra says that this vector added to that vector is RB. So let me add a small slide here. The vector algebra says that, let me show it here. It was RA, and that was RB, and this one was RBA. Okay, and then with the simple vector algebra, it will be that RB is equal to RA plus RB with respect to A. Okay, and the simplest way to see whether it is true or not, and as I told, if you cancel these A's and A's, you can see it is not cancelled, but you cannot do that. But just to check, if you just cancel A's, you can see that the result is true. And also you can do this way. You take the derivative, take the d by dt, so it will be that d by dt of RB so that will give us that velocity of B will be equal to velocity of A plus velocity of B with respect to A. And similarly, one more d by dt will be that acceleration of B will be equal to acceleration of A plus the acceleration of B with respect to A. That's what you need to know as a theoretical background for the next two problems. Okay, then I will solve the problems here.